Good day, everyone. Thank you for taking the time to be here today. My name is LA, and we are excited to have the opportunity to speak with you about Mechatronics Sensor Recommendation App, a digital reference for robotics. Before we dive in, we would like to briefly outline what we'll cover today. Our main objectives are to first, introduce the overview of Mechatronics Sensor Recommendation App, a digital reference for robotics, and two, is to discuss the project feature and methodology of the program.
Good day. I'd like to introduce the Mechatronics Sensor Recommendation app, a digital reference for robotics. So this is a console-based application developed to assist students, researchers, and engineers in selecting the most suitable sensors for their robotics and mechatronics projects. Its primary purpose is to simplify and accelerate the process of sensor selection, ensuring users that they can make well-informed decisions efficiently. So at the core of this application, it is a decision tree algorithm which analyzes users' inputs to generate personalized sensor recommendations. So the users specify their industry categories such as beginner experimentation, advanced research or industrial application, and their desired cost level. So based on this information, the system provides a tailored suggestion for sensor components that best fit their specific needs. So whether the user is conducting initial experiments, working on research level projects, or deploying industrial solutions, the app offers relevant sensor options, saving time and reducing the complexity of the manual research. So this reference aims to streamline the sensor selection process, making it quicker and easier for the users to access accurate, relevant sensor data, and ultimately supporting the successful development of robotics and mechatronics applications.
So for our objective, I want to share the primary objective of our project. So the main goal is to develop an intelligent sensor quotation tool designed specifically for users in the mechanical engineering field and in the robotics field. So this tool aims to simplify and streamline the sensor selection process, making it more faster and more efficient. So to achieve this, we utilize a decision tree algorithm which intelligently filters sensor options based on user-defined parameters such as cost and application domain. For example, the automation, control system, or the robotic design. So this means that users can quickly narrow down their choices to sensors that best fit their project needs without spending hours on research. So this tool significantly benefits the mechanical engineering industry by helping professionals and students select the right sensors quickly and accurately. This tool reduces the time spent on research and comparison, allowing more users to focus on their core design and the development tasks. So all in all, our project contributes to optimizing the project planning and accelerating innovation in areas like automation, control system, and robotics. And this supports the advancement of technology and engineering solutions.
Okay, now for the methodology of this project. So the primary programming language used in this program is Python. Data is managed through a custom sensor database organized as a list of dictionaries with each entry containing details like item ID, sensor name, categories such as energy or medicine, cost, and quality. The core components include a decision tree algorithm that classifies sensors based on user input via the recommended underscore materials function and a console-based user interface that guides user through input prompts. Output is presented in a well-formatted tables generated by label open close parenthesis and display open close parenthesis functions for clarity. Each sensor entry also includes an auto-generated clickable Google search URL for easy further exploration. Error handling is incorporated through input validation functions to ensure smooth operation. Additionally, the system can interface with Deep AI's GPT models for conversational support, although its main filtering logic relies on static data and functions. Now for the key features of our sensor management project, designed to make sensor selection easy, efficient, and organized. First, our system allows user to filter sensors based on their domain such as agriculture or chemical and within their specified budget range. This makes it simple to find sensors that fit both your application needs and financial constraints. Next, the system all sensor data in a cleanly formatted aligned table. Each row includes important details like sensor name, category, price in peso, quality to cost ratio, and a Google search link for quick online reference. This organized display helps user easily compare different sensors at a glance. Now for feature number 3, users can specify the quantity of each sensor they wish to purchase. The system then automatically calculates the total cost, allowing for quick budgeting and planning. For feature number 4, for each sensor, the system auto-generates a Google search URL using a format. Clicking the link directs users to relevant search results, providing quick access to more detailed information or purchasing options. Finally, the system supports resetting the conversation history and remembering past interactions when using AI assistants. This ensures a smooth user experience, allowing users to clear previous data or pick up where they left off.
Now, this is the program we've created, which composed of almost 800 lines of code. Then, in this part, we're gonna demonstrate how our program will work. Let's go first with program start, specific consultation, and customer or custom service rather. There's two things that will pop up, either levels or and categories. Now, for levels we have low cost, medium cost, and high cost, and for categories we have from agriculture until up to transportation. Now, let's choose low cost of let's say chemical. Then a table will pop up composing of item number, sensor name, category, quality, cost, and also the link where you can buy these types of sensor or where you can look up to their descriptions. And at the bottom of the table, we have here the total cost if you bought these items individually and all of them. Now, we'll try now the AI assistant in which we base it from DeepSeek's key or API key. Then let's say give me a sensor for aerospace use. Since it is from DeepSeek, this will take quite a while to give you a result, but it's still a useful tool for the users to use. Now, as you can see, we have here a table in which DeepSeek provided, and it is composed of sensor full name, category, price, quality cost ratio, and the purchase link. And the good thing about here is that they provided what specific store you can buy these sensors. There's also an option whether you want to continue or you want to quit. In order to quit, you just need to type the word quit. Then we go back to the home screen. Now let's try the other one, which is to show all options. So we have here all of the options written on our database, which is quite a lot considering how lengthy our program was. So let's try this. Just a sensor reference from the list. Let's say we want to have this microwave link sensor. So we're gonna write 163. Then enter the quantity we want. let's say we want six of those sensor, and let's say we choose another one, which is marine radar sensor written in item 172, and we want two of those sensors. And if you don't want to add or include any materials or sensors, we'll just need to press 0. And here we go. We have a 300,000 pesos total cost if we want to buy item number 163 with 6 items of it, and 172 number or item number with 2 of those sensors. And of course, we also added the exit button if we want to stop looking for materials to look for. Then that's it. Now, this is the end of our presentation. If you sense you're having trouble, I recommend to use our app.